Here's my report: Genetically engineered crop and pesticide use. Genetically engineered crop. GMOs have been changing the way that pesticides are used in agriculture. Herbicide tolerant genetically modified GM crops have led to an increase in herbicide usage, while insecticide producing GM crops have led to decrease in insecticide. What is GMO? A genetically modified organism is one whose genetic material has been altered using genetic engineering. Genetically modified organisms, or GMOs, are commonly used in food and medicine. This has led to concern about the dangers they might cause to the environment and the human health. The two most common types of GMOs are food and medicine. Foods: canola, soybean, golden rice, corn, and aspartame. Medicine: insulin, hormones, and vaccine. Food GMOs. Crop are modified so when farmer kill weeds with herbicide, the crops can withstand the exposure of herbicide, killing the weeds and not the crop. Although it's not as common, some types of GMOs are modified to increase their nutrient content. Corn and soybeans are two examples of crops that have higher nutrient GMO versions available. Medicine GMOs. Genetically modified medicine can be produced cheaper and easier. Some GMOs are insulin, thyroid hormones, and hepatitis B vaccine, insulin being the oldest. Other types of GMOs: the plants, the microbes, the mammals, the insects, the aquatic life. GMOs history. First GMO created in 1973. After years of testing and research, GMOs were introduced to the farmers. In the 1990s, genetically modified foods became available in store. Today, soybeans 93% of soybeans planted in the US are genetically modified. Soybeans are used in products such as animal feed, prepacked meals, and the oil is used in many industrial applications. Corn is 86% of corn planted in US falls under the category of a GMO. Maize is the most widely grown grain crop in Americas. It is used to make sugar substitutes such as high fructose corn syrup. Tomorrow, still in development, various products including vaccine, vitamin enrichment, hormones that result in faster maturation and disease resistance. Only time can tell if the risks involved in using GMOs will outweigh the benefits. What are the people concerned? Is this food safe? Should food be labeled? Are there adverse environmental effects? Patenting of seeds? Discrimination against poor? Who benefits? Genetic modification of conventional crop: 61% of corn, 83% of cotton, 80% of canola, 89% of soybeans. The other crops such as rice, tomatoes, potatoes, Hawaiian papaya, chicory, crackneck squash. Environmental hazards from pesticides: substantial health impacts on workers, pollution of natural ecosystem or waterways, loss of insects biodiversity and ecosystem, creation of secondary pests, creation of insect races resistant to pesticide. The, the advantage: reduce use of pesticide and other toxic chemicals, improves nutritional value. Many people rely on GM food for medicine. Gene technology is the best solution to the problem of the world hunger. The disadvantage: unacceptable to some groups to copy genes, interfere in food chain. Genetically engineered animals may suffer more than health problems, allergic reaction, genetic pollution. International conventions affecting biotechnology. Understanding biosafety. The concept of biosafety encompasses a range of measures policies, and procedures for minimizing potential risks that biotechnology may pose to environmental and human health. The scope of Cartagena Protocol. The Cartagena Protocol on Biosafety is an international treaty that seeks to protect biological diversity from risks posed by living modified organisms, or the LMOs, also often referred to as genetically modified organisms, or the GMOs, which are product of modern biotechnology. The protocol is a supplementary agreement to the Convention on Biological Diversity. How international treaties work. International First is international public concern over issue. The second, scientific evaluation of issue. The third is international government come together to negotiate treaty to address issue of concern, including mechanisms to address concern. International government sign on treaty to make it legally binding. And last is government pass national laws to give effect to requirement of treaty. Why do we need the biosafety protocol? Rapid development and commercialization of biotechnology and its products, including LMOs. Recognition of potential contribution that biotechnology can make to improve human well-being. Lack and limited capacities of many countries to make enlightened decisions concerning imports of LMOs. Purpose of the biosafety protocol. Contributes to ensuring the safe transfer, handling, and use of LMOs resulting from modern biotechnology that may have adverse effects on the conservation and sustainable use of biological diversity, taking also into account risk to human health. Transboundary movement procedures. The biosafety protocols regulate the transboundary movement of living modified organisms by establishing procedures for the export and imports of this organism and maintaining an information exchange mechanism known as biosafety clearinghouse. The summary. The Cartagena Protocol on Biosafety recognizes the potential of biotechnology if developed and used with adequate safety measures. Protocols is intended to ensure safety of LMOs, not to prohibit their trade. Customs officials have a central role to play in implementation of the protocol. Domestic regulation are the key. My last topic is local regulation and biosafety. State of policy in modern biotechnology. Issued on 16 July 2001 by the President of the Philippines, stated that we shall promote the safe and responsible use of modern biotechnology in its product as one of several means to achieve and sustain food security, equitable access to health service, sustainable and safe environment, and industry development. Stage and development of GMOs requiring regulatory approvals. Contained use. Laboratory, greenhouse, and screenhouse. Confined environmental release. The large-scale release. The unconfined environmental release, or the commercialization. Use for food, feed, and for processing. Primary regulatory instrument. EO 430 1990, the NCBP, which contained use, the Department of Agricultural Administrative Order Number 8, Series of 2002, Field Testing and Commercialization Direct Use for Food, Feed, and Processing. Executive Order 5114, the Series 2006 National Biosafety Framework, or the NBF. Contained use. Work is done under containment, laboratory, greenhouse, or screenhouse, and confined field. Physical, spatial, biological isolation is imposed to ensure that no viable GMOs or microorganisms are introduced into the environment. Activities are generally performed subject to specific biosafety guidelines and under specific levels of containment. The greenhouse and screenhouse. Potential ecological impacts. Genetic stability of GMOs. Reaction and interaction with organisms found in actual ecosystem. Information requirements for evaluating work under containment. Transformation protocol, the genetic and sociological analysis of donor and recipient organism, adequacy of the facility, biosafety measures, or the disposal procedures. Risk assessment policy. No person shall be allowed to import or release into the environment any regulated article without a satisfactory risk assessment conducted in accordance with the rules. The types of permit: permit to import GMOs, permit for limited release in the environment, permit for general release into environment. That's all.